So today's examples class, that's examples class 9, following on from lectures 17 and 18 from earlier this week, we'll be covering today how to calculate the p-value for a test. And we will use either Excel or tables to find p-values. We'll go through how to do that for each of the types of test. And we're, of course, this week considering an introduction to inferences based on two samples and tests of hypotheses for those two populations. Now let's have a look first at this first example, which follows on from lecture 17 example, the jewelry designer who has a concern about the jewelry that she's making, those bracelets that she's making, and whether there is a difference. In this case, we're looking to see her concern this time is that the wrists seem to be getting bigger. Now, importantly in this question, when we're looking at reading through the scenario in order to decide which test to use, we would be looking to see, do we know the population standard deviation? And if we do know the population standard deviation sigma, if we do know the population standard deviation, then of course it means we can use a Z test. Even for small samples, but in this case, of course, our sample size 36 is a large, what we would consider to be a large sample. So what we're considering here, when our concern in the claim is the mean still 5 centimeters, or is it bigger now? Is it bigger? So the concern here is that the mean is becoming bigger than 5, the original claimed value. And if we write that in symbols in a statement, mean is bigger than 5 is the way we would write it. So the complement of that statement would be the mean is less than or equal to 5. And going back to that very first idea about writing the original hypothesis, we're choosing as the alternate hypothesis here the hypothesis that does not contain the equals sign. So if we remove the symbolic notation that contains that implicit equals sign, then we are left with the alternate hypothesis. So that is the alternate hypothesis, the population mean is bigger than 5 centimeters, which means that we can write our null hypothesis to be with an equals. Mean is equal to 5 centimeters. So of course, this makes this a one-tailed test. Now, in order to find the p-value for a test, we must first calculate the statistic. And as I mentioned earlier, this is a Z statistic because we know the population standard deviation is 0.33. So this is our value of sigma. So moving on here to the next slide where this information will be turned into a hypothesis test. What we're seeing here, null and alternate hypotheses again. Mean is equal to 5 for the null hypothesis, and mean is bigger than 5 for the alternate hypothesis. This is a Z statistic, so recall that our Z statistic formula, sample mean minus population mean, hypothesized population mean, divided by sigma over the square root of n. So in our example, we have a mean of the sample 5.10 minus the hypothesized mean of 5 divided by, and that population standard deviation was 0.33 with a sample size of 36, so 0.33 divided by the square root of 36. Remember, that's the value of the standard error in this problem. So here, the top line of that fraction, 0.10, the bottom line of the fraction simplifies. 0.33 divided by 6 simplifies to 0.055 to 3 decimal places there, giving us 1.82. Now this is a Z value, and of course in order to be able to consider what this means when we're considering the p-value, we need to think about the shape of that distribution and how we show that p-value on our distribution. So this is a Z distribution. Remember, that's that bell-shaped distribution with a mean of 0, and we are looking at the position of 1.82, that Z distribution, 1.82, and the p-value is the area above 1.82. So this is a diagram showing the p-value that we're trying to calculate. Remember the value of the p-value. The p-value is the probability of getting a value at least as unlikely as our test statistic by chance, assuming the null hypothesis is true. Now, that p-value definition is in your lecture notes. The p-value that we're considering here, of course, will be the value given by the probability that Z, this Z value we have here, is bigger than 1.82. Now recall that this is a continuous distribution, and because it's a continuous distribution, we don't have to concern ourselves with removing the value at the end there. We would use 1.82 for our calculations. And of course, because this is a right-hand end probability, we'd be considering this as 1 minus the probability that Z is less than 1.82. Now, in order to be able to consider that value, we can either use Excel or the tables. And to be able to get the tables, we will just have a quick look at the Z table, which I have in another document here. Which I'll show at the end of this slide. So we're considering here the Z table, using the Z table to find the probability that Z is less than 1.82. So moving on to the next screen here. You can see that our Z table, our p-value score, is the area to the right of 1.82. So the probability inside of the Z table, from the Z table, we're looking up 1.82, and that probability that Z is less than 1.82 is a value that comes out as 0.9656. So we're going to call that 0.966. And notice that this value in the tables, you're given a 4 decimal place value. In Excel, of course, you can get that same value and use even more accuracy for it. So the p-value using a Z table or using Excel, and in Excel, the function that we'd be using is this norm dist function. And we can use norm dist with our Z statistic in the position of X, and with a mean of 0 and standard deviation of 1, that gives us the standard normal. And using true, of course, for a cumulative area from the left. Now, by now, you should be used to using that. You've done that a few times in the examples. And so, just to consolidate, we can use either the tables or Excel to calculate the p-value. Now, of course, having the p-value means that we can determine whether or not to reject the null hypothesis. And this p-value, 0.034, is the p-value for this test. And this means that if our alpha value is 0.05, and it's a one-tail p-value, the p-value is 0.034, which means that alpha is bigger than p. So p is less than alpha, so we would reject the null hypothesis. Remember, p is low compared with alpha, null must go. Reject the null hypothesis, and this means our conclusion in this problem would be that wrists are getting larger. We have evidence at alpha equals 0.05 that wrist sizes are getting bigger, which of course for the designer is going to mean more material needs to be used to make those bracelets a larger size.